Hi, 1.1c, we're going to look at f of x equals s squared minus 1 divided by x minus 1. Now what do we notice right away? X cannot equal 1. Okay. So what I'd like to tell you about doing limits is we must always factor first. Factor first. So when you're asked to find a limit, for example, if you saw a question that says limit of f of x as x approaches 1. We know x can't equal 1, but it certainly can approach it. So would we write it as limit of x squared minus 1 over x minus 1 as x approaches 1, and we say to ourselves, I can't take the limit till I factor first. So let's limit. This becomes x plus 1 times x minus 1 over x minus 1 as x approaches 1. All right, factoring first, this goes away. And we have the limit as x approaches 1 of x plus 1. Now in this case, we can put the number right in and evaluate it. Now how did I know I could do that without testing from the left or from the right? And the answer is because x plus 1 is the equation of a line. The limit always exists when you have an equation of a line. Let's graph this so we can see what it looks like. Okay, I'm just going to make a little table. If we put in 0 right here, we get 1. 0, 1 is our point. If we put in 2, we get 3. 2, 3 is our point. All right. Now we know we can't put in 1 because 1 doesn't exist. So I'm just going to put, what if we did put in 1 to find out where the open hole goes? If we put in 1 into this, we would get a 2. So we know at 1, 2, there's going to be this open hole. And then the rest of the graph is going to look like this because it's a line. It's a line that contains everything but that point right there, 1, 2. Okay? All right, very good. Now I'm going to teach you a concept. Okay. Go ahead and draw this for me. We're going to put 0 and 1, and then we're going to half it. Between 0 and 1 is 1/2. Between 0 and 1/2 is 1/4. Now let's half 1/4. When we half 1/4, we get 1/8. Now in theory, can I continue to half and half and half and never get to 0? That's right. We can continue to half and half and half and we'll never reach 0. It approaches 0. So let's look at f of x equals 1 over x. We know x cannot equal 0. But let's look at how it's approaching 0. If we were to take the limit of 1 over x as x approaches infinity, what would that look like? Okay, so if we put in a 1 into this equation, we get 1. If we put in a 2, 1/2. If I put in a 10, we get 1/10. If I put in 100, we get 1/100th. If we put in 1,000, or how about 10,000, we get 1 over 10,000. So can you see where this is heading? It's getting smaller and smaller and smaller. It's approaching 0. Okay, so the limit of 1 over x as x approaches infinity is 0. Okay, what I'd like you to do in your groups again, what is the limit of 1 over x as x approaches negative infinity? Okay, go ahead and take your time, fill out a little chart, just like we did here, but now you're going to negative infinity, and let's see what happens. while you're doing that, I'm going to draw another graph. Okay, so as you took the limit of 1 over x approaches negative infinity, you also got 0. Very good. Okay, let's draw this new graph over here. There's not much to draw, just go out to 3, go up to 2, and then at 3, 2 is a point. And then we have this horizontal asymptote, and we're going to have this look like this, where this is approaching this asymptote and this is approaching the y-axis. Okay, so we're going to call this f of x. We're going to take the limit of f of x as x approaches 3 from the right. All right, I'll give you a minute to finish that. Okay, notice if we put in 3, we get 2. If we're approaching 3 from the right, we come this way, and then we keep going. Where's f of x going? It's going to 2. Coming from the right, it goes to 2. Let's look at the limit of f of x as x approaches 3 from the left. All right, so now we're coming from the left towards 3. I'm going to put little arrows here. We're approaching 3 from the left. So as we get closer and closer and closer to 3, we're getting to 2 as well. So now let me ask you, what is the limit of f of x as x approaches 3? Right, it's 2. Because if you can approach the same number from the right and from the left, then the limit exists, and it is 2.